Hi, in this video we're going to discuss compound interest and the number e. So let's start with an example. An investment will give you 2% annual interest compounded annually. If you make a one-time investment of $100, how much money will you have in this account t years later? Okay, so let's try to model this mathematically. And let's start off by just starting with the table of values to see what's happening. So we can look at t is the number of years since we started the investment, and p of t we'll call the principal. The principal is the amount of money you have in the account. So when t is equal to 0, we just opened up the investment account. We have an initial deposit of $100. So we have $100, and then 1 year later we're given 2% interest. That's what it means to be compounded annually. Every year, the people who sold you this investment compute the interest that you're supposed to gain, which is in this case 2%. So what do? We take 100, that's our original principal, and we add to it 0.02 times 100. This second part represents the interest we gained. So that's going to be the same as 100 times a 1, because this is 1 times 100, plus 0.02. Right, so I just used the distributive property of addition over multiplication. Okay, and then the next year I take whatever this amount is, which is 100 times 1.02, and I add to it the interest I gain in that next year, 0.02 times this number, which is 100 times 1.02. But notice I have a 100 1.02 here and a 100 1.02 here. I can call this 1 times that. So what I get is 100 times, and then I get 1.02 from the fact this is 1 and this is 0.02. And then I get another 1.02. Okay, so that's all together 100 times 1.02 squared. Okay, so if you continue in this fashion, what you'll see is that after the third year, you're going to have 100, and then you'll have 1.02 cubed. Okay, so you already see what's happening. This is an exponential function. General formula for p is p of t is equal to the original deposit, the initial amount, times 1.02 cubed, or to the t in this case if you have t. So if t is 3, you get cubed. If t is 2, you get squared. If t is 1, you get this. Okay, so this is the general formula. It's 1 plus interest rate to the t times the initial amount, which is p of 0. So that's the general formula for this. Okay, so that gives us not only a table, but now we have a formula, and we could do a graph, etc. Instead, I want to talk about what happens when you change how often you compound. Here we're compounding annually. What if we replace annually goes to, say, monthly? Okay, in that case, you can do the same kind of analysis, except the times that you compound are going to come more frequently. Instead of compounding after 1 year, you're going to have to compound after 1/12 of a year, and then you'll do it after 2/12 of a year. Because why? Because a month is 1/12 of a year. So we're going to compound. This is the first month. This is the second month, because this is 1/12 of a year, 2/12 of a year. The third month will be 3/12 of the year. So you'll have to do the compounding much more frequently. In fact, you'll have to do 12 compoundings per year if you're compounding monthly. Okay, so if you look at this, then what this means is the formula changes. So what's going to happen is you have the initial principal, just as before. It's still $100. You're still investing $100. But instead of 1 plus 0.02, you're going to take 1 plus, and then you have to divide up the yearly rate. This is a yearly rate. You have to divide it up into 12 equal parts. Each month, you'll get part of your total annual rate. And then, how many times will you compound? How many times will you multiply? Well, it's no longer just T years, we're doing months. And inside T years, there's 12 times T months. So this is the formula for monthly compounding. Okay, so we can continue this to other examples. We could also, instead of doing monthly compounding, we could change that to weekly compounding. What changes there? Well, instead of dividing the interest rate into 12 equal parts, we would have to do it into 52 equal parts because there are 52 weeks in a year. And then instead of having 12 times T compoundings, those would be the monthly compoundings, now I would have weekly compounding, so there'd be 52 times T compoundings each year. Again, T represents the number of years. So by making those replacements, this becomes the weekly compounding formula. And then you could do daily compounding. What would daily compounding look like? Well, there are 365 days in the year, usually. So this would become 365, and this would become 365. Okay, so that's what happens when we try to compound in different periods of time. Now, what does this have to do with the number E? Well, there's a notion called continuous compounding. This is when you're not compounding every month or week or day or minute. You're compounding all the time, continuously. It's just continuously compounding all the time. We've taken the rate of compounding to its limit. In that case, the formula looks like this. P of t is equal to the original $100. That's how much we started with. But now we have this funky thing called E to the 0.02t. So this is the continuous compounding formula. Whenever you see this word continuous when it has to do with exponential functions, you're going to use this number E. What is this number E? This number E is something you can use in your calculator. It's approximately 2.718. Okay, so this has been an introduction to compounding, including continuous compounding and the number E.